Ignition sequence start.
Good morning. You're looking at the scene in the International Space Station Flight Control Room at NASA's Johnson Space Center in Houston. This is where there is always a team of specialists on duty to monitor the station systems and where they work with the crew members through all of their tasks on the daily agenda. Expedition 63 Commander Chris Cassidy and flight engineers Anatoly Ivanishyn and Ivan Wagner are looking forward to spending their upcoming weekend off duty, after having finished up a full week full of science support and station maintenance aboard their home in space.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Leah Cheshire. This week, Chris Cassidy continued research into how the body repairs DNA damage in space. Due to increased exposure to radiation in space, DNA damage can have long-term effects on astronaut health. The Genes in Space 6 experiment evaluates the entire DNA repair process by inducing DNA damages and assessing mutation and repair. On Tuesday, Cassidy set up the biomolecule sequencer, a device that can sequence DNA in space with a new flow cell where the samples are added. Understanding how DNA damage and repairs occur in microgravity can contribute to procedures to protect astronauts not only on the space station, but also on future missions to the Moon or Mars. In the Japanese Aerospace Exploration Agency's Kibo module, Chris Cassidy worked on hardware that gives us a much closer look at things we can't see with the naked eye. Cassidy performed lens collection for the confocal space microscopy setup and closeout, removing the lenses from the aquatic habitat in Kibo and reinstalling them to the microscope setup in the Japanese experiment module, helping maintain the microscope itself. As it is confocal, this special microscope blocks out of focus light, providing a greater resolution on the subject of interest. The confocal microscope allows data to be obtained real-time on the fundamental nature of cellular and tissue structures and functions. As we look forward to the weekend on Earth, it seems like a good chance to answer Natalie's question about what weekends are like on the space station. Like most full-time employees on Earth, astronauts in space usually get weekends off too, and enjoy talking with friends and family, taking photos out of the window, reading, watching movies, and more. However, there are a couple of tasks still on their schedules. Astronauts are still required to work out for about 2 hours each day, and they also take some time to tidy up their home in low Earth orbit. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Chris Cassidy is a U.S. Navy captain with a bachelor's degree in math from the Naval Academy and a master's in ocean engineering from MIT. He also served 11 years as a Navy SEAL with 4 overseas deployments before becoming a NASA astronaut. But you never really know someone, do you? Until you know things like their favorite musical instrument and what they hope to be remembered for. Cassidy shed some light on these things and more as the clock counted down to his 3rd trip to space.
The clock has started. Roger.
What is your favorite season?
Fall.
What's your favorite constellation?
Orion.
Favorite musical instrument?
The viola.
The viola?
Only because my kids played it.
Morning or night person?
Morning.
One thing you're afraid of?
Screwing up on a space mission.
One thing you have in the refrigerator at all times?
Pesto.
What's your favorite book?
The Count of Monte Cristo.
Favorite movie?
Saving Private Ryan.
Favorite dance move?
Sprinkler.
What's your favorite color?
Navy blue.
Guilty pleasure?
Eating ice cream.
The accomplishment you are most proud of?
Being the honor graduate of SEAL training.
The next item on your space bucket list?
Welcoming one of the commercial crews on board the space station.
Advice that you would give to younger you?
Communicate more often.
Who inspires you?
Anybody that does unsolicited, unselfish acts.
What would you like to be remembered for?
Having the greatest NBA three-point percentage.
The International Space Station is a working laboratory in space, and solar energy is a key element in keeping it running. Astronauts rely on this renewable energy source to power the machines they need for their science work, as well as the ones they need for their survival. In this demonstration video, astronaut Ricky Arnold explains the process of generating power from the station's solar arrays to produce the electricity for astronauts as they orbit 250 miles above the Earth's surface.
Hi, welcome aboard the International Space Station. I'm astronaut Ricky Arnold, and I'm currently at one of our human research facilities on ISS, where you can see centrifuges, laptops, and other scientific equipment. Across from me is another one of these experiment racks, where you can see ultrasound imaging, more laptops, cameras, other equipment, all stuff that requires electrical power. In fact, we have so much equipment for science and life support that our electrical system has about 8 miles or 13 kilometers of wiring to make it all work. So where does this energy come from? Let's have a look. From here in the cupola and through other windows, you can easily see the solar arrays soaking in the sunlight. They are massive. These 4 solar arrays are made of solar cells, which are purified chunks of the element silicon. Together, the solar arrays contain a total of 262,400 solar cells and cover an area of about 27,000 square feet, more than half the area of a football field. That's huge. When the station is in sunlight, the solar arrays produce about 60% more power than we actually need during the daytime. That extra power goes directly to charging our lithium-ion batteries. Now, those batteries are essential because they provide the power we need during the 16 night times we have per day here on the space station. The energy our solar arrays can produce is enough to power 40 homes, and we can maximize the power we generate by rotating the arrays in 2 axes, one like a windmill to track the sun through the course of the day, the other to track the sun's inclination, or its angle in the sky. The space station's electrical power system uses direct current to provide energy for our laptops, lights, water recovery system, and science experiments. Thanks for coming aboard today. Now back to Earth.
Many NASA astronauts who have been to space for an extended period of time, such as Ricky Arnold has, return to Earth with a new appreciation for the planet they left behind. It's also been true for those who took a trip to space on a space shuttle mission that only lasted a week or so. Take it from former astronaut Bill MacArthur, who has made both kinds of trips. He tells us he has definitely experienced a shift in his worldview after seeing the world at that distance.
When you first get to orbit, of course, main engine cuts off, and it's really funny. It's really not funny, but it's fun to watch everyone. I think everyone takes whatever writing utensil he or she has and releases it, because it's I want to see something float. Yeah, I know I feel floaty, but now I want to see something float. And then as quickly as you can, particularly a first-time flyer, it's to the window. The first thing you're overwhelmed with is how darn beautiful it is. It's darn exciting. And so immediately you're trying to identify geographical features, identify places. You look and you see things like a massive thunderstorm, a supercumulonimbus cloud coming up, and it really does come up at you. It is that tangible nature of what you're seeing that really does take your breath away. I worried my family when I was sending them notes because I started talking about the black velvet of deep space. You look in the sky here on the Earth, and you know, it's like Milky Way or those thin clouds up there. What am I looking at? But everything is really, really vivid, and I think that's another part of the visual aspect, whether you're looking out or looking down. It's part of the same thing of taking a picture of someone. Nothing captures vivid colors and texture and subtlety like the human eye does. And when you're in space, it's the same thing. And I think that's in part why it's such a powerful personal experience. And as much as we love the pictures that we bring back, you know, it's not the same as seeing it yourself. There's a certain serenity that comes. It's not just from what you see, it's from realizing a tremendous goal that you had. And that's something I felt right after I got on orbit the first time is, you know, heaven forbid I could perish now, or I can never fly again, but nothing can take this experience away. I own this experience. It is mine forever.
Can you imagine what it must be like for scientists who spend years of their lives developing and designing an experiment to finally watch it blast off the planet on the top of a rocket? Well, in this episode of the new series NASA Explorers, you can watch a pair of researchers go through their first experience of launching all of their hard work straight into space.
It's the launch day. It's a little windy out here today. It's a beautiful day. It's a little windy. It's got me concerned. My launch intuition is tingling a bit. I grew up here in Florida. I came to this very spot out here in the Causeway as a kid. My dad would take us to launches all the time. So personally, it's like the kid in me comes out when I come here. It's really cool. I've been on both sides of it. I've been a researcher, and then I've been now helping researchers. And I got to say, it's nervous on both sides. You have a lot of worry, I guess, as a scientist. You have a lot of work involved. As a payload provider, you hope you've checked all the boxes and you've done all that you can do to make everything work for the researchers so that they get good data. It's not easy to put even the most simplest payloads on the space station, but it's worth it. It's worth all the work. I think some of the biggest discoveries we've made and are going to find are up on the space station. It's incredibly important.
Well, we've been really nervous all the way up until right this moment. Nervous that our dreams aren't actually going to happen. But now that the larger countdown is happening and the rocket's all fueled up and everything looks like it's going to happen on time, it's getting really exciting. The last 15-minute window before it takes off. Thanks to Cases for funding this, thanks to NanoRacks for helping us coordinate and making the hardware and coordinating all the data collection too. And thank you for the astronauts who are going to be working on this project on station. So a lot of people worked on this. It's not just the two of us. It's been a lot of people. So we really appreciate all their support.
7, 6, 5, 4, 3, 2, 1, 0. And liftoff.
As Falcon 9 and Cargo Dragon take flight, bound for the International Space Station with fresh supplies and research, helping to maintain our human presence in space as the station celebrates its 20th anniversary.
It'd be incredible just to watch it no matter what, but knowing that we have a personal investment in it makes a big difference.
Yeah, so it's just knowing that something that we've been working on is on it, and then watching the whole experience makes it just different. It really, I can't find the right words to explain it. Really,
definitely feel like the work leading up to it was worthwhile.
Yeah, absolutely. And watching it with your best friend.
Yeah.
And like someone that you've been working with for such a long time, and it's just I think it couldn't get better. That's what I can say.
Yeah.
Yeah. I didn't want to do it with anyone else.
Yeah, that is the exact same sentiment that I have too. So it was really special that we could both be here.
Yeah.
And watch it together.
Our scientist experiment is officially on its way to the International Space Station. The SpaceX Dragon capsule that gives the research its ride to low Earth orbit now must make the last leg of its journey to the hands of the astronauts in microgravity.
What's neat for us is we've got cargo vehicles coming and going to the ISS all the time. It is really like a busy parking lot. Vehicles come in, they stay for a few months, we do a whole bunch of science, and then they leave again. And before you know it, the next one's coming up. Now, what's important to remember is that these vehicles cannot dock themselves to the space station. We have to bring them into the space station utilizing robotics. And what I like to tell people is performing robotics, going out and capturing that vehicle is like a really difficult video game. And so we practice over and over and over again using computer simulations on how to actually capture that cargo vehicle to bring it into station. Once that cargo vehicle docks to station, we do a series of pressure checks and equalize that pressure with the International Space Station, and finally we get to open the hatch. Very quickly the crew starts to move because we've got some experiments that are actually kept at certain temperatures, and we have to transfer them quickly out and keep them at the same temperature there on board the space station.
Elaine and Peristu's research is one of the experiments that requires quick unloading. Stored at a constant temperature to ensure the hydrogels stay intact, it's one of the first items that astronauts must remove from Dragon. Then, with the experiment finally aboard the space station, it's time to conduct science in microgravity.
This was fantastic for me. This is what I do. This means a lot to me as a clinician. And so it was really neat to be able to perform that sort of science on station.
So station 1002 is loaded.
We know that scientists play a huge role in human spaceflight missions, but there are ways students from all over the country can get involved too. NASA relies on them to take part in Micro-G Next, a challenge that allows them to put their engineering skills to the test. There is one thing that explorers all throughout time have had in common. They are all at the mercy of weather. And while things like rain and wind and lightning all factor in, you can't forget about radiation. The astronauts and the systems on their future space vehicles will have to be protected from deep space radiation. And that's why today's scientists are working hard to improve our ability to accurately forecast dangerous space weather.
The space we travel through. Presented by Science at NASA. When seafaring nations began to explore new regions of the world, one of their biggest concerns in making the journey safely was how to cope with weather. They could harness the wind for power. They could rely on the sun and the stars for navigation. They could build sturdy ships. But if a storm rose suddenly, they were at nature's mercy. More than 5 centuries later, our nation is once again on the cusp of exploring new worlds. And once again, one of our concerns about traveling long distances is the weather. space weather. While space is a vacuum, it's not 100% empty. Particles, energy, and magnetic fields travel through the void. Much of these emanate from the sun's corona, as part of a constant outward flow known as the solar wind, which stretches well beyond the orbit of Neptune. There are also high-energy particles or cosmic rays in the mix, which travel vast distances from dying stars or supernovae. Earth's magnetic field and relatively thick atmosphere act as a shield against the most harmful forms of this radiation, but in space, there is no such deterrent. If we want to travel through this space, we need ways to protect our astronauts. These particles can affect our technology, tripping onboard electronics. Dr. Yari Calatavega, space weather scientist at NASA's Goddard Space Flight Center, notes, "We are working hard to forecast when these particles will be at their peak, such as during solar flares or coronal mass ejections." Acute exposure to these solar energetic particles is a serious concern for astronauts and instruments. Therefore, having a better understanding of when to expect solar activity is important for safely sending our astronauts and spacecraft through space. Ironically, such space weather activity can actually protect against another threat to astronauts. The sun's activity can block dangerous cosmic rays coming from other stars, which are constantly present, illustrating the complexity of the system NASA tries to understand and mitigate for our space travelers. Over time, sea captains learned when to sail their ships and when to stay in harbor, based on their accumulated knowledge of the weather. It's more risky to be on the water in the Caribbean during hurricane season, and you'd want to consider avoiding the northeast coast of America during the height of winter. Dr. Calatavega says, "It's very similar to what we're doing today. We're constantly developing and testing new models to predict space weather, and we're constantly seeking new data to refine those models." A host of heliophysics missions observe space from a variety of vantage points, not unlike terrestrial weather sensors, which work in tandem to paint a bigger picture of our space environment. In August 2018, NASA launched the Parker Solar Probe to help us better understand the sun's activity, especially what drives the solar wind and how energetic particles get accelerated. This data could be used to improve models of space weather forecasting, ultimately helping us find new and better ways to shield our spacecraft and protect our astronauts. Whether it was the oceans ancient ships traveled through, or the space we will one day travel through, we know this: keeping a watchful eye on the environment around us is key to ensuring safe passage. For more information about what matters in space, visit science.nasa.gov.
The future missions just mentioned, like the ones that will return American astronauts to the moon in a few short years and then take them out into the solar system, are part of NASA's Artemis program. Artemis will bring together the Orion space vehicle, the Space Launch System rocket, and the ground systems needed to launch them both. And as you'll see, the people building these things are working hard to get everything ready to go. Take a look at the progress being made at NASA centers and contractor locations all across the country. If you'd like another look at any of the stories we featured today, head on over to YouTube and Facebook at those addresses right there in that blue box on your NASA TV screen. And while you're there, feel free to check out all the other cool stuff available about NASA and America's human spaceflight program. And if you'd rather take your space content to go, the place to go is Houston We Have a Podcast, where we hear firsthand from those working in the thick of all aspects of space exploration. We post new episodes every Friday, so today, Gary Jordan gets the inside scoop on what it takes to keep the Johnson Space Center running. You'll hear from the people in charge of center operations, and because it's that special time of year, hurricane response. Go to nasa.gov/podcast for this episode, all of our previous episodes, and the full library of NASA podcasts. You can listen to any of the above on Apple Podcasts, Google Podcasts, and SoundCloud.